Sauce here. This is a pre-algebra video lesson, measuring angles. I have a protractor here. It's a tool for measuring angles or creating angles that have a fairly precise measure. Before we get into using the protractor, I'm going to compare the scale in which we use to measure angles that we call degrees to revolutions. This idea of counting how many times we can revolve or spin or go around something. We can measure things in revolutions. Usually the things that we measure in revolutions are something that revolves many times, like the Earth spinning around its axis. Degrees are often used to measure parts or fractions of a revolution. And we've created the system of degrees. We've chosen a number that is equivalent to one revolution, or one complete spin, or one complete rotation. We've created this system that we call degrees, where one revolution is equal to 360 degrees. And when a number is measured in degrees, we include the idea that it's a degree measurement by having this little circle symbol that is drawn up to the right of the number. You can kind of think of that as the units of this measure. So 2 revolutions means going completely around twice, whatever it is that's rotating or revolving. In degrees, 2 complete revolutions would be twice 360 degrees, or 720. Degrees is more useful. It's best to measure fractions of revolutions. So if we go only 1/2 revolution, that's half of a full turn, or if one circle represented 360 degrees, 1/2 revolution would be half of a circle. Half of 360 is 180 degrees. We can give kind of a diagram to these measures. We could imagine going all the way around once, like an arrow that returns to where we started. That's a full revolution, 360. 720 would be going around once and then a second time. So 180 degrees, half a revolution is only going halfway around. Some other common fractions would be going 1/4 of a way around. And this is 90 degrees, 1/4 of a revolution. 90-degree angle is called a right angle. Right angles are pretty special in our world because we use them a lot. Half of a right angle is 45, very small arrow, and we wouldn't attempt to draw a really tiny arrow to represent a 1-degree turn or a 1-degree revolution. 45 is 1/8 of a revolution, and 1 degree is 1/360th of a revolution. Protractor then often has a scale that's in degrees. There's other ways of measuring angles other than degrees, but we'll learn those in higher mathematics. So we can, with a protractor, measure angles fairly accurately. We can also draw angles with accurate measurements if we wish. We're going to do one of each as an example, and what we're going to do is we're going to find the measure. Find the measure of an angle that I'll create now. This angle has a vertex here and has a line extended. I am going to, because my protractor is large, draw another line here. I don't know the measure of this angle because I've created it freehand. but I'm going to use the protractor to measure it. The protractor has a pivot point, often in the middle of a straight edge. And that pivot point has a mark. It's right here, off the straight edge. This is the point that I would line up with my vertex of the angle. Then I want to line up one side on the straight edge of my pivot, one side of the angle. So I'm holding the protractor so that the pivot point of the protractor is at the vertex of the angle, and one side of the angle extends along the straight edge of the protractor. This is in a position to begin reading the scale on the protractor. Notice that the scale starts on both sides at 0. I can read from this point 0 and increase the number of degrees as I go around, or if it was more useful to use the other side, I can refer to this scale starting at 0 here. But because I have one side of my angle on this side, I'm going to look to the scale that starts with 0 here. It's helpful to see the other side of the angle through a protractor that is semi-transparent, and this side of this angle I can see will end here. So I'm going to read the angle measure that will start at 0 and increase. Here's an angle measure of 10, 20, all the way to 90 where I would have the right angle, but I must go further. This is an obtuse angle. So here's 100, 10, 20, 30, 40, not quite 150, but I can get it to 1 degree as 145, 6, and 7. I'm reading this line here, 147. I'll make a note in the middle of the angle that this was a 147 degree angle. I can use a protractor to draw a fairly accurate angle. I'm going to choose to draw a 68 degree angle. I'm going to use this as a side. I'm going to use this point as a vertex again. I'm going to first I'm going to investigate where I have room for this on my paper. So I hold the protractor here where I have room, and I'm going to put the pivot point of the protractor at the vertex of the angle that I'm going to create. I'm going to use this side to be one of the sides of the angle that I'm about to find. So I have a beginning. I'm ignoring this side here. This was of the previous example. I need to find where precisely to draw this other side so that the angle I create will be 68 degrees. This side here is what I'm beginning with. So again, I put the pivot point at the vertex. I line up one side of the straight edge of the protractor with the beginning side of my angle. I'm going to use this scale here that starts at 0, and I'm going to count up to 68, which is 10, 20, 30, 40, 50, 60. Now I need to read the little lines. If I'm at 60, I'm going to find 65 here, 65, 6, 7, 8. I'm going to make a mark at the 68 degree point. So from 0 along this arc is 68 degrees. Now if I draw the side that joins my vertex to this mark here, then this angle that I found with these two sides is the measure 68 degrees. And I use the protractor to make that angle fairly accurate. Let's make a note that when we use the protractor, we put the pivot point of the protractor at the vertex of the angle. That's an essential step of using a protractor.